Greetings. I am JP Jaipunit, a student of Robotics and AI from Rama Institute of Technology. I'm doing my MTech, and this is my smart Bluetooth following robot. So this robot was built using ESP32. Its main function was to follow a particular human or a particular human carrying a particular smartphone which emits Bluetooth signals. So let's start. So the problem statement, why exactly I chose this? So most of the follow robots I came across, they had hardcode sensors such as IR sensors, or it used cameras for detecting. So what the issue which was coming in this is these camera based systems are expensive and it can fail under low light or under any occulsions. So while these basic sensors which consist of ultrasonic or IR sensors, they do not give any direction awareness, or it does not give any identity, like it has to follow me only particularly. So for that I came up with the idea of using Bluetooth. So how I have done this is I have used two Bluetooth systems wherein both of them have ESP32s and both of them have inbuilt Bluetooth in them. And then I have used a servo scanning for the direction control and a real-time logic which does not rely on any vision or any external sensor infrastructure, etc. So my main objective was to build a four-wheel robot using an ESP32 for main control. So the secondary ESP32 which is mounted on the robot, it is used to help the direction of the target device, and I have to enable a connection between both the ESP32s so that there is a no latency connection, and also to integrate an ultrasonic sensor for real-time obstacle detection, and there is a visual and audio feedback using an OLED screen which will be showing the values, if it is connected, if it is disconnected, if it is ready or not, and all those things, and a LED and a buzzer which gives us a blinking or a sound if there's any disconnection. So to create a fail-proof mechanism, I have enabled the system can return back to its home location, home position, when it is losing its signal. So the main objective is the entire system should be affordable, modular, and expandable. So this is my main ESP32 module which I have used in my project. So this is a ESP32 developer kit V1. So this has inbuilt Wi-Fi and inbuilt Bluetooth module, so it is easier for me to integrate it when I'm doing any code, so I don't need to have any external Bluetooth device, external Wi-Fi device, etc. This is my SG90 servo motor. So this servo motor is basically used for my rotations at particular angles, given specific degrees and all that. This is my ultrasonic sensor. So this ultrasonic sensor helps me to determine if there is any obstacle in the front. So when the signals, ultrasonic waves, are being transmitted from the transmitter and received by the receiver, so it means that there is something which it is hitting and coming back to. So that is used for my obstacle detection. And this is my motor driver module, L298 motor driver module. So this module helps me to control my motors at only when particular signals are being given, or only at particular for any particular given movement. This is my IMU module. So this module has an accelerometer, a gyroscope, a magnetometer, a barometer, as well as a temperature sensor. So this my particular usage here is the accelerometer and the gyroscope. So this helps me to go back to the location where I am coming from. I mean the robot. It helps the robot to go back to the location where it's coming from if the signal is lost or anything as such. This is my buck converter. So this I'm using because I have a single power source which is of 12 volts, but my sensors need 5 volts of power and my motors need 6 volts to 12 volts of power. So since I cannot use the same bus bar for anything, I am using a buck converter which will help me to step down the voltage and take the output. I'll just show all that in my project. So this is my main block diagram. So I have a target device. One second. Yeah, so I have a target device. So this target device is my smartphone, which I'm going to carry, which will have the app and where the Bluetooth will be enabled. So I will have my RSSI measurement. RSSI is my signal which is being emitted by the Bluetooth device. And I have a scanner, ESP32 angle estimation. So my robot has a scanner which will keep scanning for that particular RSSI signals from the smartphone, so that nobody else Bluetooth is being disturbed or no miscommunication happening. and then I have a UART transmission. So this UART transmission is basically my RX signal from my main controller ESP32 and my TX signal from my ESP32, which is giving me the Bluetooth signals. And then the main ESP32 makes the decisions. Yeah, it makes the decisions and controls. And then I have my L298 and motor driver module, which will help me for the robot movement. And I have the main feedback here is the ultrasonic sensor and the signal timeout. So even though this whole process is a loop, this is also another loop inside that particular loop. So in this video demonstration, I can show you how the robot's movement happens. So if you can see here, the robot is rotating at particular angles, and if you can notice here, yeah, it is the same. The ultrasonic sensor is scanning for obstacles, and I can see that particular display in my OLED. So this is just a basic test which I conducted for the ultrasonic sensor only, without moving the motor, without connecting wheels and all, which I will be doing in the further steps. So in this one, if you can see, so here I have my motor module, the whole module. So in this you can see the ESP32 is also rotating. Yeah, if you can see that, and my motor is moving and it is following me right now. This particular robot is following me because you can see that this is again scanning continuously, the ESP32, and the ultrasonic sensor is also scanning. So since I just gave my phone on that side, the robot is able to rotate, and you can see the ESP32 is also rotated at that particular angle where the phone was given to. So if you can see in this particular video, this is just for my basic motion control which I did to check if my robot is able to handle the weight of the equipments, the battery and all that. So yes, it was more or less able to, but it was not that fast because I had a power bank as well as a battery power source. So as you can see here, the ESP32 module as well as the robot, both are continuously rotating, scanning, and my wheels are rotating as the movement is forward. So this is a basic working of the project. I'll be showing the real project also in some time, but this is just a demonstration. So the PPT ends here. I'll now proceed with the actual presentation of the project. So here is my actual robot. So this robot has an ultrasonic sensor. It also has a main ESP32 module. So this is the main ESP32 controller, and it also has a ESP32 controller mounted on the top. So this particular ESP32 is only used for my Bluetooth giving signals. It doesn't have any other purpose in this particular project. So this will rotate at different angles like this, and it will give me the Bluetooth signal through this UART connection. If you can see here, I have connected it to the transmission port TX2. So that is in turn connected to the receiving port of this particular ESP32. So this is it, and this is the ultrasonic sensor which will keep scanning at different angles, which is again using a servo motor only. So if there's an obstacle detected, it will look around and see which side is the obstacle coming from. So it will give me a free direction on which side I have to move to. So taking a look at this side, this is my buzzer, and that's my LED. So I'll be getting audio and visual feedback as well. And also this is my OLED display. So where I can see different readings, different values and all. This is my main power switch, which is being connected to the battery directly. I have mounted it on a box so that when I'm demonstrating it right here, it doesn't run away or doesn't rample my systems. So that is why I've kept a box so that I can show the wheels rotation and all that. And after that is my, if you can notice inside, I have the L29D3 motor driver module. So this is the module which basically controls my wheel rotations and all that. And these are my basic BO motors. These are my basic BO motors for rotation. In this side I have a bus system. So this bus system has input of 5 volts coming from this particular point. So this 5 volt is being connected here. So it is being distributed as plus and minus at this point. So anywhere I need to access 5 volts, I'll be taking it from this particular bus. And so that's it. That's it of the construction part. Let's go to the actual working. And this is my buck converter. So I have 2 buck converters. So one is for 5 volt and one is for 6 volt. So this 6 volt goes directly to the motors. I've used a thicker wire so it indicates that it is 6 volts and it is going to the motors. This is 5 volt. So there's a common circuit connection on this. So let's get to the starting of the robot. So as we can see, the module is powered on. We can see 5 volts and 6 volts at both the ends. So I have two buck converters doing the job for me. And I have two displays, so it is easier to understand. So this side of my display has the code for my main ESP32 controller. And this particular side of my code has the Bluetooth scanning. So as you can see that in the serial monitor of this one, you can see that it says no device found, no device found, because no device is being enabled still. So this robot is not getting a command to follow a particular device or a particular Bluetooth target device. So that is why the robot is still stopped. The wheels aren't rotating. So the robot is at stop. So we will connect the robot to the Bluetooth and we will see that this changes. So if you can notice, it is saying at each 30 degrees, which it'll be giving me the best angle found at each of these. So it will scan for my RSSI signal from the phone and it will give me at which particular angle I have the best RSSI signal. So let's start that. So right now I'll be using an app called NRF Connect. So this NRF Connect helps me to advertise a particular Bluetooth signal from my device. So what I can do is I can go here and I've already created an advertiser which will give me the Bluetooth signal emitted from this particular device. So the advantage of this is how apps use Bluetooth to emit Bluetooth continuously without losing signal or without stopping it. So let me just start this. So when I start this, I can see that I have a complete list of 12-bit service UUIDs. So this is my UUID. So this UUID is the same which is being added in the code. So my ESP32 will be able to identify what is the code or what is the ID it has to search for, what is the ID it has to look around for. Okay, so let's start that. So as we can see, I'm using this particular UUID which I just showed you in the screen recording of the Bluetooth advertiser. So it is still scanning and it is not able to find a device. So it will continue to scan as long as it is able to find, and only after it finds it will be able to start the rotation of the wheels, as in the motor will start moving. So it is still scanning, if you can see, and it is searching where is the device which I have to connect to. Yeah, as you can see, it is connected and it says that it is giving me angles at different particular degrees. So I can see the same on the OLED also. So this OLED is connected to my main ESP32, whereas this particular scanning is being done in my Bluetooth module. Okay, so the Bluetooth module is continuously scanning, and this is the angles and its particular RSSI signals. It also returns me the best angle at that particular scan. So it will say the robot to move left or right based on that. So the robot is now moving forward because my phone is my Bluetooth device and I am exactly in front of it, so I cannot take it completely left or right. So it says best angle is at 0 degrees since it is directly in front of it. Okay, so that is how the scanning happens. I've connected the wire just to show the output, so we can function without the wire also. So right now that is the only task of that is to show the output in the particular serial monitor. Yeah, so if you can notice, when I kept an obstacle, as in when I just showed my hand, the LED over there glowed, and then the ultrasonic sensor is seeing which side is free for it to go. So I'll just show you again. So the LED glows. So the ultrasonic scans again, and you can see there is a difference in the rotation of the wheels. I'll just show you once again. see it is gonna take a turn. Yeah, so it took a turn and it is gonna check which side is free for it to go. So that also is being displayed in the OLED. So let me just show you the OLED. See, when I'm putting an obstacle, it says obstacle and it says left is free, so let's go left. So it says it's turning left. So let's show again. It says back because I haven't removed my hand from the scanner part. So it is still obstacle. It is having an obstacle at every part. So it says obstacle, obstacle. So let's go back. Let's go back. So that is what is happening. So it is still scanning, scanning. So that is what is happening over there. So if I just remove my hand, it is gonna. Yeah, it is again looking for the RSSI signal and it is moving forward. The scan is being done again and again over there. So this robot basically follows you everywhere you go, and just in case somebody walks by when it is following you, it will also be able to detect that there's somebody in the way or something in the way, some bag, some animal, some anything in the way, and it will be able to change its path and again follow you back again based on your RSSI signals. So these same signals I'll just show you. You can see it here also. Yeah, so it says angle, the best angle is 90 degrees, so it is moving forward. It is giving me the best angle at every particular scan. So this is the main scanner part which does all the scanning. So that is how the robot functions. So as you can see, it has taken a pause. That pause was because it was not able to detect the RSSI signal immediately. So even though it is not getting signal, it will not just move vaguely. It will wait. It will wait for it to scan and then only it will move. So I didn't talk about this. So this is my ProRange 6000 mAh power bank. So this gives me an output of 12.2 to 11.1 volts. So this is what is being given as input for the buck converters. So this is the project overall. Yeah, so as it is running, I have my main power source. Okay, the wire got disconnected, but this is my main power source. So which if I turn off, the robot will stop running and all the motors will stop. So the basic idea for this was to follow the person. So this can be enhanced in the future by using any strong Bluetooth modules which will capture the Bluetooth signal more efficiently. And so this is the basic robot. So this is the final prototype of the model. So as you can see now, it is running without directly on the power source, without any USB devices, and that will give you the, sorry that is not visible, but that is the angle which we just saw previously. I'm not able to focus. So this robot is now running autonomously, and any obstacle, it is going to change its direction and it's going to continue running. So this is the final working model. So thank you for the presentation.